How's it going? Good, good. My name's Neil. I am a software engineer. Work for a company called Robotics right now. Primary stack that I use is Ionic.js, Nest.js, and got one other one, React. And that's all I use Typescript. So today, all of our examples will be in Typescript when we go later on. So that's all going to be good, I hope. If not, feel free to ask questions about any of it. As we go from slide to slide, feel free to ask questions about the concept as well. We'll take time to discuss, and I'll leave time at the end to go over some things. So today we're going to be talking about general design patterns. So I guess to get started with that, what are design patterns? Design patterns are existing strategies that help us overcome common developer problems. That's generally what they are. They are generally language agnostic, and they can be implemented as needed in any library or any language or framework that you're currently using. It may differ just depending on how, what paradigm the language is using. So you may have to tweak that to your needs. But because it was based out of object-oriented programming. So in your functional languages right now, you probably, or like if you're using JavaScript and going more functional, or like Erlang, whatever, they probably have their own little cookbooks and design patterns that they use. But today we'll just cover the basic, the object-oriented programming part of it, and then I'll show an example for some of them all of them are in React, but some of them have been implemented specifically for React. So I guess the history of it, as you can imagine in your current workplaces, right? So we're talking about why we use them. You usually have common sets of issues that you face. Depending on the domain will be different, right? So you might be in banking, or you might be working for like an airline or whatever else. You can program for anything, but you'll find that there are general problems that you encounter that you can actually reuse different concepts, or I guess templates for solving the problem in a different domain. And so back in 1994, 4 guys known as the Gang of Four created a book. They canonized a set of what they found to be patterns that existed for solving problems. I'll say their names. I might butcher it, but it's Eric Gamma, Richard Helm, Ralph Johnson, and John Placides. And so, yeah, their book is called Design Patterns, Elements of Reusable Object-Oriented Software. And so that is the primary source of most of the design patterns that we have today. There are obviously ones that have been created since then. Languages have changed, obviously, and more patterns have been created. You see a lot of cookbooks or recipes for your different frameworks, but a lot of them will stem from their original work. So they divide them up into 3 sections. You have creational, structural, and behavioral. Yeah. Creational, as you can imagine, it focuses on creating objects, finding ways to build something repeatedly, and a lot of their principles are taken from like solid principles, or I guess general like clean code types of principles. Then you have structural, which literally represents the structure of the code, and so ways to structure, break down a problem, and then structure your code in a way to solve that problem piece by piece. And then there's behavioral, which deals more with the logic side. So those are going to be a lot of your algorithms. They'll have those sorts of problems, or patterns dealt with, problems for those problems, patterns for those problems. So let's see. Yeah, that covers that. So one way I like to think about it is like cooking. So I enjoy cooking. I'm by no means an expert, but I do enjoy it. And what I found as I cook different recipes and stuff is that there are patterns that exist for that. So with programming, it's the same way. In cooking, one of the things that you learn is, or that I've learned from, I guess, a chef, his pattern is called a tile becomes a slice, slice becomes a dice. And so in that, with using his method, you can find ways to cube cut anything of different sizes, right? So you can see in the example here, you have a carrot that's cut into tiles. That's what number 1 is. And then if you take those and set them, you can cut them again they'll become slices. So if you want like a julienne, that's what that would become. If you flip them, you rotate them 90 degrees and cut them again, they'll become dices. So you can imagine if you took a potato and cut the same way, you'll still get dices out of it by following this pattern of cooking or cutting. And then similar to programming as well, not all the times you want a fine dice like that or fine slices. So you can always kind of tweak the way you do it to fit the problem at hand. So if you want stew, your potatoes are going to be chunkier, so you can increase the width of those cuts and so on to create what you want. Programming patterns are the same way. You'll take a basic template and fit it to your situation. So you do have to be aware of when you're using these design patterns, make sure it's the right fit. And that's what this next slide is. So each pattern that you learn is like a tool in your belt, but that tool has an express purpose. And a lot of times you'll find programmers, especially out of college, and I did this coming out of college, is every problem that you see, you automatically try to find a pattern that fits it. And sometimes it just doesn't. So some of the similar issues that you have are, you have over architecting something. So you can take a problem that's really simple or doesn't require a lot of complexity, right? You try to architect the heck out of it. And so you'll put patterns around it everywhere. And the next thing you know, you've actually overcomplicated your code. It's hard to maintain. It doesn't actually solve the problem at hand better than another way would. So that's one of the issues, is you can over-architect something. The other issue is if you pick the wrong pattern for the problem. Let's say you learned about a certain pattern, and because let's say you know 3, and because you only know those 3, you're going to try and take those 3 and fit it to every problem that you encounter. That's also not the right way to do it. So you do have to be aware of, you have to be conscious of the choices that you make when you program. And you may ask, well, what's the purpose then, right? Why should I learn patterns if I can over-architect something, or if I can choose the wrong pattern for this problem, whatever? That kind of just comes with experience, right? So as you become a more senior developer over time, even senior developers will learn new things about patterns and how to use them. And so you're always going to be balanced. It's always a balance. And I think that's the cool thing about development, is that it's like cooking. You can learn to season, balance your solutions, and know when it is time to use a pattern and when it's not time. So that's just my 2 cents on that. We can just go ahead and jump into some patterns now. With that in mind, we know creational, structural, and behavioral. Any questions before I move on? Concept-wise, it's kind of the introduction to it, what it is, why we use it.
I got questions. I don't know if you might answer them though.
You can ask. I'll push it if I will answer it.
Okay, cool. So when you think of structural, I'm thinking I go straight to like, okay, different layers and components inside that. Is that what you're thinking, or is this?
That can be one way to do it. How to structure components, right? If you're thinking in React, then there may be patterns on how to structure something, how to structure a certain problem. Usually, it doesn't deal with file structures, right? It's more like, how do you structure your classes? When to use inheritance versus composition in React. A lot of it's about composition, right? So you usually with React, you'll drill down, and so you'll say, instead of me, so inheritance is I am this, right? They favor composition, where you're going to take a conglomerate of things. You'll say, this is going to have access to these services or these hooks, context. And so those React concepts actually use those patterns behind the scenes, right? But we will cover an example of, we'll go one by one. I got one example for each, and I think we'll have enough time for it. Yeah. So the first pattern I want to talk about is the observer pattern. The observer pattern is behavioral. So this diagram here is just kind of, it encompasses a problem statement, right? So the problem being, you have a subject, which could be an object in your code, and you have a bunch of clients or entities that want to observe that object. In this case, they're taking Twitter, right? And they say, you have something that you're following, so I'm becoming an observer to that subject. The subject is the person I'm following. I am an observer to that. And I want to know when an event takes place. I want to know when something happens to this object. In this case, maybe they're sending out a tweet, and that's what it looks like here. They send a tweet out. That subject needs to be able to tell everybody what happened. Hey, I updated. So your typical, if you're familiar with PubSub, that's a similar pattern. It follows that pattern where you have something that's being observed. You have observables that are watching for certain events, right? So this is UML. These are diagrams that are created to encompass the solution to a problem. I'm not going to get into how to read it too much. We'll just briefly cover it. But if you are getting into learning or want to dive into it more, then you'll want to learn how UML, I think it's universal markup language. I'm not sure about that U, but I'm pretty sure that's what it stands for. But I'll explain what's going on in this diagram. So right here, you have the subject, right? Oh, shoot. All right, so you have the subject, and the subject in this case I had this as an interface, but you can also you can create it as just a class as well. But right here, the subject has an array of observers, which is private, and it has methods on it. Yeah, the minus means private, plus means public. So it has methods to attach and detach the observers, right? So you can imagine if you have a Twitter user and you're following, you're going to attach yourself to that subject. That subject will provide a method to attach, detach if you unfollow, right? Notify. So what happens is that notify right there, you see that ... it goes down to a function. That notify is going to iterate over each of the observers in the array and call an update function. And that's what you see over here is the observer, right? This observer is an interface that all it does is it defines an observer as something with an update function. When you implement it, you can add other functions, whatever, some other business logic, doesn't matter. But what you do have to have is update, and then usually some context. I put any because that context could be the subject itself. It could be a portion of the subject. It could be the name of the event that took place with some other contextual data, what have you. So that observer is just an interface that states anybody that implements me, you have to have an update method that takes in these parameters. And you can do whatever you want. I don't care what you do. The only purpose of it is that the subject is eventually going to call update on you. And then it's your duty to do whatever you want. I don't care. So let's go into an example. I'm going to close out of this. I don't know how these transitions are going to be. All right. So let's go to my app. I tried to make it nice, but it's not cooperating. Actually, I'm sharing my whole screen, so I can pop this out now. I think. Okay, here we go. Or not. It's being a little slow. All right, cool. So I guess I'll show you that after. Let's go into the observer code. So I've got my patterns here. We're going to go to observer. We're going to do the classic example. We'll start with the types because I think that makes the most sense. So in your types, it's pretty simple. All you've got here is an interface. I call it subject classic. It's just a subject. It says anybody that implements me, I need an attach, a detach, a notify method. Attach, you don't specify how it's done. You don't care how it's done as the interface, right? You're going to leave that up to whoever's implementing it. So if you come down to, and then we'll go ahead and just cover all the interfaces. Then we have an observer. An observer is the thing that's going to be notified when something happens. So name there, that's just for my convenience. And then update, the update method right there, I'm passing in the subject itself. And so I'm saying when something takes place, I'm going to call update. I'm going to pass myself into there. The observer can do what they want with my information. So the situation that I have created is a traffic monitor. So the idea being there's a traffic monitor subject, or let's just say a service, right, that exists. And when something happens, I want to notify whoever's observing the traffic. So what we have is there's your private collection of observers or your array of observers. The message queue is for my convenience. The accident location. So usually there's a piece of state tied with what you're going to be observing, right? In this case, you want to provide, as a traffic monitor, it's beneficial to give accident reports. So the location in this case. My constructor simply stating that when I instantiated, I'm going to have an empty array. And then again, that's the message queue for convenience. Then we have the attach method here. So all we're doing, we're taking the observer, we check, hey, does this observer already exist? If it exists, then I'm going to put out a message. The observer already exists. I'm returning now. If it doesn't exist, then I add it to the message. I add a message to the message queue. I attach the observer, and then you simply push the observer onto that array for later. Your detach is going to do something very similar. It just checks to see if it exists. If it doesn't exist, then it says, hey, I don't exist, return. If it does exist, then we splice it out of there and add a message that has been detached. But you can see how it doesn't really matter what language you're in, right? Like it's pretty clear here that you can take this framework and place this template over some other language and it work just the same way. Syntax would be different.
But this, you used an if statement, right? Is it different with this language? You don't use an else or what? Else?
So what I did, and this is just something that I'm used to doing, you don't have to, right? So this is called a guard statement. And a guard statement checks for a condition. And it says, if this condition is met, then I'm not going to do anything else. I don't care about what's below. So on this return statement, when this return is called, then it just exits out of the function and I don't have to worry about anything else. You could implement an else. You could check if the observer, you could say if this exists and I want to do this stuff, but then you have to return. For me, it's simpler. It requires less lines. And I think it's clear when people read it.
So you could do this without doing else, right?
Yeah, perfectly fine. I mean, I could throw that in there and this is going to do the exact same thing if I put that right there. Not a problem. Then we have a notify. This one, again, it's, we add, I'm notifying the observers for the message. And when it's called, I do this observers, I just iterate over each of them, call update, I pass in the object. Then down here you have, this is the business logic, right? So what happens is someone's going to call accident event and give a location. And when this happens, the location is set. I say there's been an accident, and then this is what actually will call notify, right? So that's that. Then you get to the observers. I'm not going to go over each one because they're repetitive. So I have two. I have the news channel observer, and then I have Google Maps observer. Again, name for convenience. That's convenience. You don't even need, you'd have an empty constructor if you didn't use that. All you need is the update statement right there. And all that's going to do is going to say, hey, if this subject is an instance of, so if it is a traffic monitor subject, if somebody calls update and is that, and then there is an accident location, then I want to add this message, hey, we've heard there's been an accident, right? And likewise for Google, it's going to say, hey, I'm rerouting you to get around this point. So if you want to see an action, the way it works, observe classic. We're going to run the example. And then I did this so the reason why I created the message queue is so that we can see step by step what happened in the execution, right? So if I click print next, the first thing you see is traffic monitor attached observer Google Maps observer. Let me open up the client code really fast so you can see that. So in the client code, we simply create the traffic monitor, create Google Maps observer, news channel observer, attach both, and then I call, hey, there's an accident event, I-24 west of Briley. Very realistic. So there's your first one. You've attached the Google Maps observer. Next thing that happens, you attach the news channel observer. Then you'll see there's been an accident. That's when this was called. Then the next thing, notifying observers, and we'll see two printouts, one for the maps being rerouted, and then one for the news channel. Hey, we've heard there's been an accident at the I-24 west of Parkway. I think that's it. Yeah. So press next, nothing else comes. So that's how that pattern works. Any questions about that? You could talk about how it was, the syntax, how it was created, pattern itself.
But what did you use to make the interface?
That's React. So I'm using React for everything here. I've got an example runner. So basically this run test function is what does the business logic or that logical part. And then this example runner, it's pulling messages off of a queue. And I provided, I'll show you.
Like, I mean, with the colors and the buttons. And...
Oh yeah, that's a material UI. It's called, I guess, called MUI now. That's what it stands for, at least. But
that's what you told me about earlier.
Yeah. So that's all coming from right here. So you got your button group, whatever. Easy way to just throw something together real quick and standardize it. Any questions about that? All right, let's move on. We can cover the observer react pattern real fast. We're going to hit time quickly. Yeah, please, Dustin.
Would you like to
Sorry.
You wanted to something
Oh.
there?
You mean like that?
No, the other one.
Which
The
one?
other
What view?
Your other page. Go to the breadcrumb at the top left. The menu.
Yeah, top left.
Yes, sir.
All right.
Farther to the left. File menu. Yes, sir. View. Editor layout. And then full layout at the very bottom.
Flip full.
So which one?
Yeah, that's great. That's awesome. All right. So the React example, the difference here is that we have two components that do it. The main difference for this is that instead of the observer being a class, it's a function, right? So you're specifying what the type is. So component to be an observer is simply going to have this observer function in it. So you specify the signature for that function. In this case, I don't know that I want to talk about the generics right now, but suffice it to say that it's a function that just takes in a subject and then returns void. So if you get down to, so this traffic monitor subject is all the same stuff, I believe. Yeah. Down here, we do export a traffic monitor here. So we export the traffic monitor service straight out of there. And then in the example, we have the news channel. You'll notice here, all we do to implement that is we've got this on accident updated. That's going to follow that function signature. So we've got the observer, which is just a callback, right? So it's just I take in a subject and I'm actually going to update a piece of state here. And so the piece of state is just the accident location. And then when that changes, so you'll attach, so you have the tracker monitor, so you grab that service, you see I'm going to attach this callback. If this component detaches, or component, yeah, if the component detaches, then detach this observer here. And then we use that bit of state, the accident location, to generate the message that's put below. The same thing's happening in the Google Maps. There's your function there on accident update. And then you attach yourself to the monitor or the subject and then call that down there. So if you want to see it in action, the way it works, you come into here, you can say I-24. If I trigger accident, then both of them update, right? So it's a simple pattern, but fairly effective at communicating. So you can imagine on the back end, you can implement this to call events to different APIs, right? So you could have an API service on the back end that people are calling your API to attach themselves to be notified about some event that takes place later. Another thing that I didn't include here is that instead of just saying attach, you could say attach this observer to a string of this event, and that event would be mapped to the function that you're going to call later, right? So if I'm interested in a particular event, this one's only one event, but if I had a bunch of events that people could listen to, then I could implement that and have them pass in a second parameter to that attach function, and that would define which event to pay attention to. So something to take note of, that'd be really useful. How much time do I have?
I mean, you could go to 7:30.
Okay, cool. Cool. No questions about that stuff so far. Okay, sweet. Let's move on to the next one. Where were we? Server factory. Okay, so the factory pattern. The problem statement here is usually a class can't anticipate the types of objects that's going to create, right? So this is a creational one. So yeah, it can't anticipate types of objects it'll create, or requires subclasses to specify what kind of objects it's going to create. So if, for instance, we're taking the logic out of it and saying, we're going to let somebody else deal with the details on how this object is created. I just want this type. So in the example you're seeing right here, the problem statement is they have client code that's using this transport function, right? But you can transport things with the car or with the boat. You don't want your client to know which one, doesn't matter. All they know is that a vehicle is going to come and transport something. So you can solve this problem by using a factory method, which will allow you to say, hey, I'm going to pass you a transport object. They don't care what kind of transport object. There's going to be an interface over that abstracts that away. And all they know is there's going to be a dot transport method or something like that, right? So if we go to the pattern, oh, I didn't connect those. That's okay. So we have a product. The product is usually the result of what the factory creates. So back in this example here, the product would be either a road logistic or a sea logistic, I guess a truck or a boat, right? So the product, you'll have the product, which is the interface that's going to do something. So all these products are going to share similar behavior, and that's, or similar action. In this case, it's just do something. And that's what this concrete products is down here. So they all implement that and say, we'll do something, we'll do it however we like, but we will do that same thing just in our own way, right? And then you have a factory, which is actually going to create those products. So you have a create product method on your factory. This is it could be an interface or a class, depends how you want to implement it. In some cases, you even have a separate, if it's an interface, you'll have separate concrete factories that create the concrete product that they pair with. So that function there, all it's doing is, let's say you call create product, you're going to pass in the kind, the type that you want. And then based on the type, it knows how to create those objects. So I can show you an example of that. All right, let's go to the types. So I was thinking about it in terms of like a game or something where you have monsters that you want to create. So the monsters would be the product, right? The monsters all are going to do what? They're going to attack. That's a similar thing that ties them all together. So in my monster product, all I have to specify is you need to have an attack function and you're going to return out a number. I don't care what you do in between there. That's all you need to do. Then you've got message queues for my benefit. Here's all your monsters. You've got a puffball. And so you've got this message here. They return 1. The slime, same thing, returns 2. Frost slime, 4. And then you have your monster factory. There's an enum up here that has the types. That's for my convenience. And we actually switch off of those. So basically I have a class, the monster factory is going to create a monster product down here. Notice that it doesn't have a frost slime or whatever. It's returning the base interface. If you, the interface all the way up here, the monster product, it's not returning out any type of these. It's not going to be that specific. Because at the end of the day, the client that's going to use it is just going to call attack. They're going to tell me what they want, and then they're just going to use the attack method off of it. So we switch off of that, and depending on which enum it's using, we return the type of monster. And then a lot of times the factory methods here, I don't actually call this, but there's usually some business logic that is attached to the factory, and they can use whatever, they can actually at their convenience switch out and use whatever kind of product they want as well, and it'll still work. So let's look at the example. So factory example here, and all you do is create a new factory. And then what you can do is, all right, so this is just code to generate 10 random monsters. So what it's doing, you got your array, you fill it, you map it. The sample is going to pick a random between the values available, and then that's going to be used to actually create the monster. So 10 random monsters, that's my monster army. And then what I'm doing here is I'm calling monster array dot for each monster attack. Notice it doesn't care, right, what type of monster it is. They're picking random ones. It can always call that attack. As a matter of fact, this right here, you could say that this is a monster product. So you can say it's type monster product array, and it respects that. And so they're all going to be treated the same way. So with the runner, what happens is if you click on the factory classic, we run the example on that. The first, wait a second. Let me reset the example. There we go. I'll explain that later what happened. So it created 10 random monsters, and then it called the attack function on it. So puff all attacks for 1, and I can do this 10 more times, 2, 3, 4, 7, 8, 9, 10. And that's what you got. So questions about that? No? All right, cool. The last one that we'll talk about is a singleton. Very common, and it could be very misused. So the singleton is basically a way for you to be able to access the same object and only have ensure that there's only one instance of it in your code, or in the runtime, I guess. And why might you want to do that? Sometimes you want to ensure a certain number of like database connections. That could be one reason that you want to use it. Sometimes you want to put a lock on things, right? So you say, if you're going to go through this method, I can ensure, and I guess in other languages, you use like a mutex or something to make sure that it can only be called once at a time. And if it's in use and nobody else can use it, you can use it to pull for things. So if you want a single place where something's pulling and you want to receive that information from the same place, this is another reason why you could use it. And its implementation is super simple. So the way it works is it's literally a single class, and what it has is a static method or a static instance of itself, and then it has a get instance function. So you have a private constructor on it. The private constructor makes it so that nobody else can create another one of these objects. The get instance function, it's a static method as well, and so you'll call the class.getInstance, and it's going to return itself. And so whenever somebody uses getInstance, it'll create it the one time, and every time after that, it's going to return itself, right? So that ensures that nobody else is creating a new one. You're always accessing the same object. It's pretty good. One of the ways it's misused is kind of similar to all global variables, really, is it's very easy to want to implement it, right? It's simple because if you think about it in terms of React 2, it's like you're misusing context. Just because I can shove data in one place and access it there, it doesn't mean that you should always do it. There needs to be a specific use case for it and a reason why you do it. Otherwise, it's easy to get especially for debugging purposes, it's hard to know who's doing what. And so you probably want to put in fail safes if you were to implement this pattern. Let's get into that pattern. There's no actual example on here that you can see other than I'm using a singleton for that messaging component. So the reason why I was clicking print next, right? And you were seeing messages coming in not from this example. And the reason why is because I was using the singleton pattern, and it took a previous example that I clicked run example on, and it had queued up the messages. And so when I was clicking print next, even though I clicked run example here, it pushed those messages onto that stack. So let's look at that. My head's probably really big on that. All right, so we've got the message queue right here. All it does, there's your private static instance of message queue type, because I'm going to hold a reference to myself. I have the queue. That's the state that I actually want to control and track. So I have a string array there. There's your private constructor. Nobody can say new message queue. It's impossible. There's your get instance method, which returns the type. And this is the bit of logic that makes it work, right? So it says, well, there's two. It's the private constructor and this method here. So the first thing it does is it checks, do I already have an instance of myself stored? If I don't, then I go ahead and I assign it. So I do a new message queue and I assign it to myself. And then I return that out immediately. So if it came in the second, somebody calls get instance the second time, what's going to happen? It'll come in, it'll see I'm already created. I'm going to go ahead and give myself to you. Sound odd. And then you have here, these are my methods I wanted for the business logic, right? So you have add message. What's it going to do? It's going to take that queue, push it on, or a message, and to push it on the queue. The retrieve function, I just check if the queue length is 0. If it's 0, I just send a quick message and I return out. Otherwise, I just splice off the last one or the top one, right? So that's going to turn the messages in order. And then for convenience, I also have a clear message, which is what the reset example uses. So if you look back in the actual, I don't know where I was going with this. That's unused code. The example runner. What we do is we go ahead and access that message queue, right? So I call message queue.get instance at the beginning here. And so I have the instance to that now, right? And so now what I can do is I can say, hey, I want to retrieve it when somebody calls print. So when I click this button here, this next button right there, then I want to pull a message off of that queue. I'm going to set the messages, which allows me to iterate over them and display them below, right? The reset button here calls reset, which accesses, so it sets my local state to an empty array. And then I go ahead and use that message queue instance to clear itself. And so that's being used in two places. That's used here in the factory classic and the observer classic. So if you go to the observer example, you notice it has the same component here. So I don't have to share that class anywhere else. It's isolated up there. And then I think those are the only places it's used. Yep. And so if you want to see an action, then what we do is if we're in classic, right, I can run this example for the observer classic. I can come into the factory classic and run that. And now if I print this, the print next, you'll notice it's doing the traffic stuff, which was the observer classic. So we know that it's only one instance that has the previous messages on the queue. And I'm printing those out. And after that, it's going to switch to the factory stuff. So that's how, that's where I say, be careful when you choose to use certain patterns. It's not always going to fit. In my case, I don't mind. I think it shows the example quite well. But yeah, if you're running prod, you don't want issues like that happening. Yeah. Any questions about that pattern? I mean, any of the previous patterns fine too, but if not, that's all I've got. So some additional resources, right? You want to learn more about it. Refactoring Guru does a good job of explaining design patterns. They have modern examples. They have all the most of the examples are in TypeScript. I think they do a good job of showing pseudocode if you want to implement other languages. They do a very good job. Design patterns, if you really want to get into the nitty gritty, elements of reusable object-oriented software, they go in depth about it, but all their stuff isn't like small talk and they're old languages. So when you read through the example, they are harder to get right off the bat, but they do provide, I think they provide UML tables. So you would want to learn a little bit about UML. And you can learn as you go. It's not something where you have to learn all of it and then dive into that, right? And then the last thing that I would recommend is the book Clean Code, Uncle Bob. That's pretty much a standard in development. So if you're going to read any book, that's a go-to. He talks about principles of clean code, how to architect your stuff, ways to keep your code efficient, mainly for readability, right? Flexibility, maintainability, the reusability, those types of things. He covers how you can achieve those in your own code. And that's not to say that all of this stuff is exactly the way you should do it, but that is a good place to start. And at least if you follow his stuff, you can't go too wrong.
I have a question.
Sure.
Might be a stupid question, but in the Singleton pattern.
Yep.
So if you have like user A and user B.
Yep.
Do they each get their own version of that, or do they share?
It's the same version.
Okay.
So let's go back to the example, because what's happening there, right, is because it's a static, when the code runs and you've imported this in and it reads it, it's reading in that class, right?
Mhm.
So it's accessible at one point. And so the second that somebody calls that function, it's going to instantiate the object, but that class is static. So, well, not the class is static, but the methods on it are static and stuff. So it only can call that function and it only returns out the same.
Okay.
And that's going to be across the board if you've implemented the singleton pattern correctly. Now, where you might see an issue is if you had the constructor public and somebody had called new, you could have multiple instances and it drive you crazy, right? Because you'd expect them to use the same thing and then you'd be getting different things. So imagine with this messaging one, if I had expected it to have the same message queue, but I was only getting half of the messages here, half of the messages there, I'm thinking, where is it going? Likely there's multiple instances, which meant that I built it wrong.
Sure.
So you would see that as a bug if you wanted it to, if you didn't want that, right? If you wanted to create a separate one, then all you would do is open up that constructor. No need for the get instance. People can create whatever they want. In React, what you would do, what you could do is if you didn't want to do it like this, you could also have something like I think that's what I was building over here is a message queue service. And what you would do is instead of having this private constructor and whatever else, you could build an instance of it and keep a reference to that object, right? So if you keep a reference to the object and pass it back, whether you're going to pass it through hooks like a use hook, or if you're going to put it up in context and have people reference that, then you could achieve the same thing without doing it this way. So like I said, with different languages and frameworks, they provide methods to use the patterns in their own way.
Okay. Does that static keyword, is that kind of the key piece to sharing that object?
Mm-hmm.
across
So
multiple?
yeah, so the static keyword, what it allows you to do is so let me show you where it's called, right? So if you actually come into, let's go to the example runner. So if you come here, you'll notice I've imported message queue, right? So there's a class, but how's it called, right? I call it directly on the class, and that's what the static, I don't know, keyword is. That's what it does, is it allows you to take the class and call that method directly on that class without having to instantiate itself as an object.
Yeah, it's
Right.
similar in .NET.
What's that?
So it's similar in .NET.
Yeah. Java does the same thing. It's very, very similar. Well, TypeScript is a Microsoft baby, right?
Sure.
So, anyways, there's your additional resources, and that's it. Thanks.
Nice.
Yeah.
Nice, dude.
I really like your example. It's so great.
Appreciate it.
I like